major role. Okay. So what is JVM? JVM is a abstract machine. It's a virtual abstract machine. So basically, which is used to run your programs. And so basically, it's a computing machine. So that enables a computer to run your any Java programs. So JVM specifically performs 4 tasks. One is loads the code first into JVM. So that is one of the JVM component will do that. So in yesterday's diagram, I have shown you that. And verifies the code, executes the code, provides a runtime environment. These are the 4 tasks JVM performs. So JVM inside, Java bytecode is going to be executed by interpreter component. So let's understand the internal structure of a JVM. So what is different components are there, and let's understand that internal structure. Oh, so what happened suddenly? Why this diagram is not showing?
Yeah, I was trying to look into it while I was studying. I couldn't find it, so I tried Googling one.
Mm-hmm. Okay. Oh, something happened here. Okay. Let me see why this is not loading. Code Java introduction. Still not loaded. Oh. Okay. Let me show you. Then we'll diagram is important. Till yesterday it was there.
Image could just be missing today for all we know.
Yeah. This is the way I took. Oh, here also missing. Some loading issue. So here also it's broken. Image is broken. Let me see. I think this guy also will give properly. Yeah, you can see this. Okay. This is a high level. You can keep. So we have a class loader. Then there's a first component. Then we have memory areas. Memory areas, you have class area, heap, stack, PC register, native method stack. Then we have execution engine. And then we have native method interface. and Java libraries, all the Java code. So the Java code they have already written, right? That code will be there. So a class loader, main purpose of class loader is, so class loader will load the class files. The dot class file is there, right? The dot class files will be loaded into JVM by this class loader component. This is one of the sub components. So in Java, JVM, okay. So it's a part of JVM inside, okay. The purpose of class loader is loads all the dot class files. So the dot class file will generate it after compilation. So that's what I have shown you in the yesterday's diagram. It will compile the human readable code and stores in a dot class file. So the dot class files are input to the JVM. Who will input that to the JVM? This class loader. There are a different type of class loaders we have. Bootstrap class loader, extension class loader, application class loader. So what are the three types of class loaders? Bootstrap class loader, extension class loader, application class loader. So what is a bootstrap class loader? So which is responsible for loading classes from the bootstrap class path. So nothing but rt.jar file. So rt.jar is a predefined jar file. When you install Java, automatically you will get this jar file. So that jar file will be loaded. So whenever you require that jar file related classes, anything you are calling, that will be loaded into JVM by this bootstrap class loader. So the highest priority will be given to this class loader first. Next, extension class loader. So the extension class loader is responsible for loading classes which are inside the ext folder. There is a JRE lib folder inside. You have this ext folder. That ext folder inside all the jar files will be loaded. So into JVM by this extension class loader. The last one, application class loader, which is responsible for loading application level class path or path mentioned in the environment variables. From there, it will be loaded into JVM. That is the application class loader. These are the three types of class loaders. So are we clear? Or anything you want a class loader related? What is the main purpose of class loader?
Oh, it's to compile the code, right? Bring it in.
Yeah, no. So
Oh, it's
already,
loading class files into the JVM. Yeah.
exactly. Already compilation is done by compiler. The compile time you will get a file that is a dot class file. Who will do compilation? Who will do compilation? The compiler. Java compiler.
Java C.
Java C. That's a compiler, right? Compiler will do the compilation. First compilation will happen. Then only execution. Without compiling the code, code won't execute. First compilation will happen by the compiler. That compilation after, you will get a one output file. That is a dot class file. Dot class file will generate. So that is the input to this class loader. Class loader will take that class file and loads inside the JVM. Loads inside the JVM. So I have shown you yesterday a diagram. Similar, there is no change at all. So that, this is the one. The application class loader will load into that. So these are all existing code. Existing code will load into the class JVM class loader. Once it is loaded, okay, once it is loaded, So it will verify. So, right, it will verify, the bytecode verifier will verify whether the generated bytecode is proper or not. If verification fails, we'll get the verification error, compilation failure, something like that. So in the same time, it will prepare for all the static variables memory. So will be allocated and assigned with the default values that will prepare. And a resolve, all symbolic memory references are replaced with the original references from the method area. So there is a, so memory areas right here.
Mhm.
This is the class area is called method area. And this is the heap, stack, PC register, native method stack. So these are the 5 memory areas. What are the 5 memory areas? Class area, heap, stack, PC register, native method stack. So these are the
Okay,
4
I found this on the web. Register
memories.
stack. Check it out.
5 memories. And the class loaders are 3 types. Now, execution engine. So execution engine, you have a different components. Again, interpreter, just-in-time compiler, processor, all this will be available here. So before going to this, let's understand what is there in the class area, what is there in the heap, stack. These memory areas you should understand very well. If you are not clear on the memories, and it's very difficult. See, in the method area, all the class level data will be stored here, including static variables. So there is only one method area per JVM, and it is a shared resource. All the shared data will be stored in the method area. So that is before execution itself, first this data will be loaded. So once the class is loaded, class loader is loaded, then the first all the static data will go and store here. Okay, so that's the once the class is loaded. So it will go to memory areas after loading the class. Whatever you declared in your class, that will go and store in the memories. Somewhere you have to store, right? So that's a static data will go and store in the class area. Static methods or static variables, it will go and store in the class area memory. So this is one of the memory. Next. So we have a heap area, heap memory. So all the objects and their corresponding instance variables and arrays will be stored in the heap memory. So what are the things will store in the heap memory? All the objects and their corresponding instance variables and arrays will store in this heap memory. Runtime data, we call this runtime data, will go and store in this heap memory. So there is one heap area for JVM. Each JVM, one heap area will be there. So since the method and heap areas share memory for multiple threads, so that data is stored is not thread safe. But so what data? So final conclusion is heap memory means the objects will store, runtime data will store, instance variables will store, arrays will store in this heap memory. This will be at runtime only execution time only the data will store here, not when you load the class. No, you have to create object. Once you create object, then only that data will come and store here in the heap memory. I'll explain again. I'll come back to this. As of now, understand. Stack area. So stack area is for every thread, a separate runtime stack will be created. So stack means, last in, first out, right? LIFO. It will work on LIFO based. For every method call, one entry will be made in the stack memory, which is called stack frame. All local variables data will store in the stack memory. A temporary method inside data, so that will store in the stack memory. So the stack area is a thread set. So because it is not going to share so with other resource. The stack frame is divided into 3 sub-entities: local variable array, operand stack, frame data. So these are all 3 kinds of stack frame will be divided. So basically in the stack memory, you remember a temporary data will be stored, local variable data. So method inside whatever the data you store, that data will go and store in the stack memory. And every method you are calling, right? For every method, a separate stack will be created. That one stack frame will create. That frame inside, that method related data will store. And once that method is completed execution, then that will be deleted from the stack. That's why local variable data you cannot use in another method. The reason is it won't be available. Once the method execution is over, that will be deleted from the stack memory. So why local data you cannot use? Because it's not there in the memory. If it is there in the memory, you can use. If it is not there, you cannot use, right? So that is the reason. So why local data is not available in another method. Every method has its own stack frame. Once that method execution is over, that frame itself destroyed in the stack memory. So that is the stack area. So PC register, each thread will have a separate program counter register, we call this. To what it holds? It holds the address of current execution instruction. Once the instruction is executed, the program counter register will be updated with the next instruction. So one by one byte code stream is coming, right, for the execution. So what is the current execution? That will have some address in the PC register memory. So once that is done, so the next one will be updated. So old one will be cleared off. Next one will update in the same area. So that is called PC register. The current instruction will be updated with some address in the PC register. Then native method stacks. So native method stack holds the native method information, like already developed methods, right? Those information will be stored here. For every thread, a separate native method stack will be created. So that's all about memory areas. It's a very, very important topic, memory areas. So there are 5 memories. One is a class area, heap, stack, PC register, native method stack. So, and we'll come back when we are progressing a little bit, okay? Variable topic when comes, I'll come back here again.
So then the previous concepts, do they come hand in hand with when you're mentioning, right? When you're like initializing a program or something, you say public, static, void, int, main, right, and all those things. Is this what it's related to? Like overall, like when we're calling those things?
That is just a program, okay? One program we have written. But one method is there inside that. Now I'm going to write in the Eclipse also. I'll show you that, okay? So that you will, same program will write, and I'll show you that. How the program will execute, from where it will start, and everything we will understand step by step. But this one, you can understand more when you reach the variable topic and methods topic. This memories, you will understand when you reach that variable topic and methods topic. Okay. I'll come back again for this part again, because this is the crucial. How strong you are in memory understanding, how strong you are managing the memory, that much speed your application will maintain. If you are so performance of your application is not good, means something your memory management is not good. Okay. Okay. So next execution engine, next component. First we have seen class loader. Then we have seen memory areas. Now we are seeing execution engine, very important component. So the byte code, which is assigned to the runtime data area, that means memory area, will be executed by the execution engine. So once it is assigned in the memory, okay. So here it will store here, right? Then execution engine will go and pick the data from this memory, right? That's what this execution engine will do. The first component of execution engine is interpreter, just-in-time compiler. So then you have a processor, garbage collector. So these are the different components inside the execution engine. Interpreter, just-in-time compiler, garbage collector. Garbage collector is a crucial. Okay. So what this interpreter will do? Interpreter, so interprets the byte code faster and executes slowly. So the disadvantage of interpreter is that when one method is called multiple times, every time a new interpretation is required. So that's a problem. So basically interpreter will execute your byte code stream one by one. So just-in-time compiler, so basically it neutralizes the disadvantage of the interpreter. The execution engine will be using the help of the interpreter. It will speed up the execution process. That's what this just-in-time compiler will do that. And so to improve the performance, and there are multiple components are there in the just-in-time compiler. Again, intermediate code generator, so code optimizer, target code generator, profiler. So these are the components will be available in this just-in-time compiler. So not that much, important. You don't need to bother about that. Third one is a very important, garbage collector. So garbage collector collects and removes unreferenced objects. That means you created objects, you're not using them. Those objects all collected by garbage collector and clean up them. So garbage collection can be triggered by calling system.gc method. System is a class, and that gc is a method. So, but the execution is not guaranteed. Garbage collection of the JVM collects the objects that are created. Automatically, you have frequently it is going to run in the JVM system. You don't need to schedule by just calling this method. Okay, so they're not required. It will be frequently it is running. You don't need to run again. So main garbage collector responsibility is it will clean up unreferenced objects. It will remove and clean up unreferenced objects. So what are the execution engine components? Interpreter responsibilities. It will execute the byte code stream. That's just a simple one line here you can tell. Just-in-time compiler, which improves the performance of the application, performance of the system. So that's a just-in-time compiler purpose. Just one liner, if you add, that's enough. You don't need much also, okay? So what is the garbage collector responsibility? It collects and removes unreferenced objects. So that's the main purpose of garbage collector. And garbage collection of the JVM collects the objects that are created. So when you create them, it will collect them. And any object you are not using, it will find out and clean up from the memory. So that's the main purpose of garbage collector. So if it is not doing, garbage collector is not responding and it is suspended, and then your application will become very, very slow. So that I faced this issue. So in one of our applications, then we increased the heap memory, then it started working properly. So that's why understanding the memory is very important. So, okay. Now, last one, JNI, Java Native Interface. JNI will be interacting with the native method libraries. So, and provides the native libraries required for the execution engine. So native libraries means all the code that are already developed by Java. So that you can so get it from these libraries and you can supply it to execution engine. And native method libraries. So this is a collection of all the Java code, so which is required for the execution of your bytecode stream. So this is all about JVM components. So what are all JVM components? JVM is a simple abstract machine which is used to execute your Java bytecode stream. So Java bytecode, Java JVM will perform 4 tasks. One is loads the code, verifies the code, executes the code, provides a runtime environment. That's the JVM responsibility. What are the internal structure of a Java JVM? So class loader is the one of the component. And class loader main responsibility is to load the class files which are generated by the compiler. The compiler will generate a class file. That class file will be loaded into JVM by class loader. So there are 3 types of class loaders we have. One is bootstrap class loader, extension class loader, application class loader. Then we have a bytecode verifier will verify the bytecode stream is proper or not. If not, it will throw error. And so again, memory areas. We have 5 memory areas: class area, heap, stack, PC register, native method stack. So class area, so it will store all the static data, static variables will be stored there. And heap memory, so basically it will store instance variables, arrays, and objects that you created that will store. Runtime data will store in the heap memory. And stack area, all the local data it will store. For each method call, each method invocation, one stack frame will create. Once that method is executed, that frame will be destroyed from the stack. That means the entire local data will be gone once the method execution is over. Till method execution only that variable data, local variable data is available in the stack memory. Next, PC register, which are the instruction currently executing that will be registered in the PC register memory. Next, we have a native method stack. All the native methods information will be stored in this native method stack memory. Next, we have an execution engine. So execution engine is basically, we have 3 components: interpreter, just-in-time compiler, JIT compiler we call that, and garbage collector. So interpreter will execute the bytecode stream. Just-in-time compiler will improve the performance of a system. And then we have a garbage collector, which is mainly used to collect the runtime objects that are created during runtime, and collects all the objects and removes any unreferenced objects are present. So that means unreferenced means nobody using that. You created, but when you create object, memory will be occupied, but you are not using that. Then the JVM, this garbage collector, will identify that, and it will pick up and it will clean up from there. That's what this garbage collector main responsibility. So Java native interface, JNI we call this. So it will be interacting with the native method libraries and provides the native libraries code to the execution engine. Then we have native method libraries already. So all the native code, so which is required for the execution, it will be taken from the existing code. So that's all the components of JVM. So JVM plays a major role while so executing your code. Say a virtual machine is a software implementation of physical machine. So Java is developed with the concept of ORA, write once, run anywhere, which runs on a virtual machine. The compiler compiles the Java file into a .class file. Then that .class file is input into the JVM, which loads and executes the class file. So that's the complete what is mean by a JVM, right? So now after joining back, let's go and install all the softwares. So we need some softwares and we'll install all of them one by one. So you have Windows machine or a Mac laptop?
I have a Windows PC.
Okay, so no problem. So now we can install Java once you join back. Okay, so
Sure.
Let's join back quickly and immediately join after ending this meeting. Yeah, we'll end this here and let's join back.